Texan Global School, Implicit Differentiation. In this class, we analyze implicit differentiation processes. It is important to have the formulae with the differentiation rules at hand. Also, remember the chain rule seen in previous classes and its adaptation of the formulas with the chain rule. The functions seen in previous classes have the form y equals f of x, which express a variable explicitly in terms of another variable. However, the functions defined implicitly using a relationship between x and y have different differentiation processes, especially for those cases in which we cannot represent the equation explicitly, that is, isolating the y variable. Therefore, implicit differentiation is a method that consists of deriving both sides of the equation with respect to x and then solving the resulting equation for y prime. Essentially, the process involves first deriving both sides of the equation. Since y is a function of x, we must use the chain rule. Solve the equation or isolate the derivative of y with respect to x. Let's look at the first example. We will differentiate the equation x squared plus y squared equals 4 with respect to x. That is, we must find y prime. We can see that it is not represented explicitly since the variable is not isolated. This particular case could be adapted by first isolating y and then differentiating with the previous processes. However, we will do it with the implicit differentiation process. First, differentiate both members by applying the notation and rules of differentiation. In this case, the derivative is applied to each term. Now we can see that the first term is derived with the power rule, so x squared is derived as 2 times x to the 2 minus 1, resulting in, since y is a function of x, we will use the chain rule applied to the power rule for the second term. So the derivative of squared y is 2 times the 2 minus 1 times the derivative of y, which we will later write as y prime. On the right side, the derivative of a constant is 0. Now solve for the derivative of y with respect to x, which is y prime. In this way results the derivative, which is negative x over y. In this next example, we will differentiate with respect to x. The equation x cubed plus y cubed equals 4xy. We can see that it is not represented explicitly because the variable is not isolated. In this case, we cannot adapt it by isolating y. Therefore, we will follow the implicit differentiation process. So, apply the derivative on both sides, and by differentiation rules, the derivative is applied to each term. As we can see, the first term is derived with the power rule, so x cubed is derived as 3 times x cubed minus 1, or 3x squared. Now, since y is a function of x, use the power rule with chain rule for the second term. Hence, y cubed is derived as 3y squared times y prime. On the right side, apply the product rule, which is the first factor times the derivative of the second, plus the second factor times the derivative of the first. So the derivative of 4xy is 4x times the derivative of y, plus y times the derivative of 4x. Hence, differentiate the missing factors of each term. The derivative of y with respect to x will be represented as y prime, and the derivative of 4x is 4. By changing the notation, we can isolate y prime to obtain the derivative. In this way results that y prime is equal to 4y minus 3x squared over 3y squared minus 4x.
Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com